earlier, lectures in virology, remember we talked about classification of viruses based on diseases they cause, and we shall continue following these viruses based on the diseases, how they are classified based on diseases they cause. And today we're going to look at a number of viruses which actually cause a disease called gastroenteritis. But as you're going to see in the next slide, gastroenteritis is not caused by viruses only. But gastroenteritis, first of all, in terms of definition, gastroenteritis is defined as vomiting and diarrhea. That's a common a layman's definition of gastroenteritis. And it is because of the inflammation of the stomach, the small and the large intestine. So that is what is referred to gastroenteritis. So what causes gastroenteritis? Number one, gastroenteritis can be caused by parasites. And I'm sure you're going to learn about parasites when you are doing your microbiology this year. And parasites like Giardia, Lamblia can cause gastroenteritis. We also have bacteria that also cause inflammation of the stomach, the small and the large intestine. Example are Salmonella species, Shigella, Sonnei, and the others. But for us, we are only interested in gastroenteritis that are caused by viruses. So remember, when you are asked to, during exams, give examples of viruses that cause gastroenteritis, don't give an example, Giardia lamblia, because it's not a virus, right? I know most of you. Oh, can you hear me, Kelsey?
Yes.
Okay, I'm seeing a message. I think this is an earlier message, right? So we will be focusing mainly on the viral gastroenteritis, and will not be touching anything to do with either bacterial or parasitic gastroenteritis. And so my slides, they're not moving. You can still see my slide? Yes?
Yeah. Yes.
Yeah, I think they're smaller now, but I'm not sure why they're not moving when I put them on full screen. Oops. And so, first of all, let us look at the epidemiology of viral gastroenteritis. Number one, as I've said earlier, that gastroenteritis is caused by parasites, it's caused by bacteria, and it's caused by viruses. But when we look at the burden of gastroenteritis, put together, we're told that 75% of gastroenteritis are due to viruses. So viruses contribute 75% of gastroenteritis. Number two, if we put all diseases caused by viruses and arrange them in order of which one contributes to the largest burden of human disease, we know that upper respiratory viral diseases are the most common viral diseases, followed by viral gastroenteritis. So viral gastroenteritis is number two when it comes to the burden of diseases caused by viruses. Number three, in developing countries like Kenya, most countries in Africa, Asia, this disease, viral gastroenteritis, is still a killer of infants. Children born, less than 6 months of age or 5 years of age are likely to die because of viral gastroenteritis. And so, there are a number of viruses which the way these viruses end up causing, inflammation of the stomach, the small and the large intestine, is that we ingest these viruses either by eating food contaminated with the virus or by drinking water contaminated with the virus. And these viruses, they must be able to pass through the stomach, and they must be able to pass through the small and the large intestine. In addition to that, these viruses have the ability to replicate, to make new variants along this path, along the stomach, along the small intestine, and along the large intestine. So they replicate in large numbers. But one interesting thing about viruses is that there are viruses which are actually ingested through the same way, right? You ingest them through either food or water. They go through the stomach and the small and the large intestine. They replicate, but they never cause the inflammation of the stomach, the small and the large intestine. And we want to look at examples of these viruses. Number one, poliovirus, for example. I'm sure we've learned about poliovirus in earlier lecture. Poliovirus is transmitted through the fecal-oral route, which means you either ingest the virus in contaminated water or food. The virus goes and replicates in the intestine. A large part of it is excreted in the stool for further transmission, but some of the virus then enter into the bloodstream and go into the central nervous system, where they then cause damage of the central nervous system. So polio virus would not necessarily cause inflammation of the stomach, the small and the large intestine, although they pass through the same route. Other viruses are like Coxsackie A and B, enteroviruses 68 and 71 to 71, but that is A and E. And then we have a unique group of adenoviruses, viruses called adenoviruses. These viruses are many. There are over 200, versions or types of adenoviruses. But despite the fact that they are in the same group, they cause different types of diseases. For example, adenovirus 1 to 39, they are transmitted through fecal-oral, they go through the stomach, the small intestine, large intestine, they replicate there, but they do not cause, the inflammation of these organs. So these are some of the viruses that, they can be found in the gut, but they never end up causing viral gastroenteritis. Which viruses, just to wake you up in the morning, do you think are actually causing viral gastroenteritis? Because I'm sure this is not the first time you are hearing about the word gastroenteritis. Can I see your responses via the chat? Which viruses? Astroviruses, noroviruses, rotaviruses, calciviruses, toroviruses. Good. I think you guys either read a lot before the lectures or you get these lectures from your colleagues, which is good. Yeah, so all the viruses that you have listed so far are associated with the viral gastroenteritis. All the viruses that you have listed, I can see, are all related to viral gastroenteritis. And so we can look at, so this is the list, and I'm sure all of you were able to get this. So I want to point out two viruses here. Number one is rotaviruses. Number two adenoviruses. Remember in my previous slide, I talked about, those viruses that, are ingested or are taken by drinking contaminated water. They end up in the stomach, the small intestine, and large intestine. They replicate there, but they don't cause inflammation. And I talked about adenovirus 1 to 39. But here you can see that another group of adenoviruses, adenovirus 40 and 41, are also transmitted the same way adenoviruses 1 to 39 are transmitted, but adeno 40 and 41 actually do cause inflammation of the stomach, the small and the large intestine. So these adenoviruses are able to cause viral gastroenteritis. We shall look at, sorry, my voice is very bad, so we shall look at, I'll be slowing down a little because of my voice. I want us to take a look at, one of the viruses. We want to take a thorough look at it, and then I will let you read the others at your own time. So I'm sure you guys have know a lot about rotavirus. It's a very common viral disease, and the way it looks like on under electron microscope is as shown there. So as I mentioned to you, please, you need to memorize the photo. I'm sure you guys, all of you, have photographic memory. I'm hoping that you can look at this and then remember this. So this is how the rotavirus looks like under electron microscope. In terms of, I will go back to those slides. In terms of the virology of the virus, you can see is an unenveloped virus. Remember what we talk about, viruses that are able to go through the gut must be non-enveloped viruses. So the virus is non-enveloped, but it has a double shell. The outer, I don't know whether you can see my cursor. Are you able to see my cursor? Yes. So it although it is a naked virus, if you look at it, it looks like it's an enveloped virus. It has a double shell. The cover, whatever is protecting the genome of the virus, is arranged into a shell. This outer part and the blue one, the one inside here. Okay, and so the genome. This is an RNA virus. Remember, viruses are either RNA or DNA. But one unique characteristic of rotavirus is that the rotavirus, the RNA is arranged in segments. So you have genes packaged into parts, what we call segments. So these segments, they code for 6 structural and 5 non-structural proteins. Structural protein means proteins that are associated with the formation of the parts of the virus. And the non-structural proteins are proteins that are associated with things like, enzymes that this virus would carry. Most viruses, do code for, enzymes that they carry with them, which are very specific to the virus. And then if you look at, if you look at this picture, you can see the proteins are arranged as they are numbered. We have viral protein 1, we call it VP1 and VP3. They are sitting at the same position. it's difficult to distinguish the VP1 and VP2, VP3 by looking at this diagram. Then we have VP2, which is here, and then viral protein 4, viral protein 6, and viral protein 7. We shall come back to talk about the importance of one of these proteins later. But on this slide, I just wanted to show you the virology of rotavirus, that it is a naked virus. It has a double-shelled, cover. It's an RNA virus with 11 segments. Each segment, the 11 segments, 6 of them, code for the formation of structural proteins, and 5 codes for the non-structural and structural protein. So, in terms of classification of rotavirus belong to a family of viruses called Reoviridae family, and that is one. Number two, within the rotavirus itself, it is further subclassified into 5 different species. So we have rotavirus A, which is the most common cause of human disease. We have rotavirus B, which also causes human disease, but is mainly common in China. It is not common in other parts of the world. I don't know why. So then we have rotavirus C, D, and E, which are not necessarily human pathogens. So it is important to note that. And then further, rota group A virus, as I said, are important human pathogens. They have, 2 proteins which are important. That is VP viral protein 4 and viral protein 7. And these proteins, the reason why they're important is that when the virus gets into your body, your immune system is able to recognize the virus through these proteins, and they produce, your body responds when producing neutralizing antibodies. What is the importance of neutralizing antibodies? Yes, why do you think neutralizing antibodies are important in terms of response to a rotavirus invading your body? Can I see the response on the chat? Why are neutralizing antibodies important when you are invaded by, to limit toxicity of the virus, not necessarily to avoid the attachment? Yes, they block the virus from attaching to the cells of your cells of the body. Phagocytosis, no. My friend Songok, today umeamuka vibaya. You're always right. That is opsonization, no. Memory, no. What's happening today? Beth Thomas. Neutralizing antibodies. Have you guys been taught about immunology? Have you been taught about immunology? Yes or no? Yes. So then you should know the importance of neutralizing antibody. They prevent binding of the surface protein to the host. That is correct. Neutralization is a very, generic common word. Neutralize, like you hear the war in Russia and Ukraine. We have those things called anti-missile. You understand? So when a missile is coming, being thrown from Russia, the Ukraine would send anti-missile. So anti-missile will grab the missile in the air and neutralize it. So just the same way, neutralizing antibodies also, they bind to the virus and protect the virus, prevent the virus from attaching to the cells, making the virus not to cause infection. So the 2 proteins which your body recognize and produce proteins have 2. are the VP4, viral protein 4, and viral protein 7. And so a little bit about rotavirus still is that rotavirus is the major cause of diarrhea in infants in the world. As we said earlier, think about this. We said earlier that gastroenteritis is caused by parasites, bacteria, and viruses. But I also said that 75% of gastroenteritis are due to viral diseases. Further, we are now saying that rotavirus causes about 75% of all gastroenteritis. So it is the most important cause of viral gastroenteritis. Infants are the main culprit for rotavirus, infection. When they get infected, they become very sick and they can die. However, adults are not left out. Even adults can get infected with rotavirus. The good news is that when you get infected with rotavirus as an adult, the disease is not as severe as it is in children, and you are not likely to die because of rotavirus infection, because you should have suffered rotavirus infection before, and you have some level of protection in your body. The third thing about rotavirus still is that rotavirus also infect other animals. And it is very common for rotavirus to infect small animals. These are like calves, children to cows, piglets, the children to pigs. And this is why children are more likely, those kids who are crawling are more likely to get the infection, because they're likely to be crawling on the ground, probably playing with the dirt that has been soiled by these animals. So the virus is not only a human virus, but it's also a virus that can also infect other animals. So I think we've touched a little bit about epidemiology. If you look at this map, this map is just showing areas where rotavirus burden is, and those red dots show you the density of the magnitude of rotavirus globally. If you look at the continents, North America is almost clean. North America includes US and Canada. It's almost clean. There's a bit of rotavirus in South America. But if you go to Africa, now you can see there's a lot of rotavirus in Africa. Kenya, we are also, painted red with those red dots. And the worst is Southeast Asia. The southern part of Asia. You can see how rotavirus is common there. And this is purely because of poor sanitation and the heavy population in those countries. That is why the burden of rotavirus is very high in these countries. We have already touched about this. I talked about the family of rotavirus and the different species, A to E. We've also looked at the structure of rotavirus. So transmission rotavirus is by fecal oral. So meaning that you are eating feces and you get feces, because people don't think that you can eat feces, but you eat it indirectly. When we drink water that's contaminated with feces, or we eat vegetable or fruits that are contaminated with the feces or the virus. It could also be the person, if you go to eat in a restaurant, someone who is handling the food is infected, can also transmit the virus to you by touching the food if he has not cleaned his hands properly. So, but we are also told that, you know, the high numbers of viral particles are shed in stool. So like 1,010, particles of virus per gram is so many that you only need to eat and ingest a drop of water or food to be able to get infected with this virus. So, sorry for my voice is getting worse over time. I want us to to look at the clinical presentation. If my voice disappears, then we stop the lecture. So when you get the infection of rotavirus, either by drinking contaminated water or eating it in the food, the virus stays in you for about 3 days. And after 3 days, then the symptoms start appearing. And the major symptoms are vomiting and diarrhea. Those are the two major symptoms of rotavirus. So as I said, the virus causes inflammation. So when the virus causes inflammation of your stomach, if any food goes there, it irritates the stomach, and the stomach throws back. So you start diarrhea. Vomiting rather. The same as if the stomach, and the small intestine and the large intestine are inflamed, anything that touches there is removed immediately without giving it time to be absorbed. So the main two symptoms for rotavirus are diarrhea and vomiting. But as this continues, then you start losing a lot of water in your body, and you start getting dehydrated. And if you get further dehydration, it can lead to shock, and it can also lead to death. So these are the consequences of vomiting and diarrhea. Also note that not everyone will present with these symptoms. These symptoms are common in people who are getting the infection for the first time, and the severity varies with the age. The younger you are, the more severe the disease, and the older you are, the less severe the disease. A number of patients do recover within 3 to 8 days. And when you recover, you develop, partial immunity to rotavirus disease. So my voice is disappearing polepole. I don't know how. I will slow down kidogo so that we finish this lecture. So how does this virus end up causing, vomiting and diarrhea? I want us to look at the pathogenesis due to rotavirus. And this light that I'm showing you kind of explains the pathogenesis of rotavirus. Which cells of the small stomach, small intestine, and large intestine are usually infected by rotavirus? Which cells? Nakunywa lemon bwana. Bill, I'm trying to take lemon, but sauti inaanza kupotea kidogo. So bear with me. Yes, correct. So rotavirus infect, enterocytes. These are the epithelial cells lining the stomach, the small and the large intestine. Allow me to take 1 minute break, please. 1 minute break. I'll try to speak slowly. hoping that my voice will be okay. So looking at the diagram I'm sharing with you, the cells that you are seeing there are, the enterocytes. These are the cells that are covering the stomach, the small and the large intestine. You can see, I hope you're seeing my cursor. This is the rotavirus. As like any other virus, they would infect the cell by first attaching to the cell cell wall, cell membrane rather, and then they inject the RNA or DNA to the cytoplasm, and then the replication starts. So now this is what rotavirus does when it enters into an enterocyte. As it makes its own new virus, which is one of them is represented here, it also makes an excess of a protein called an NSP4. NSP4 stands for non-structural protein 4. Remember, we talked about rotavirus as having, 11 genes. 6 of them code for structural proteins, and 5 of them code for non-structural proteins. So these red triangular that you are seeing here are produced in excess during the replication of rotavirus in an enterocyte. So the virus is leaving this cell. Usually the virus don't kill the cells per se. Then as the new virions leave the cell, a lot of them are now, have been thrown out of the layer that is covered by the epithelial enterocytes. But they also release this protein called NSP4 protein on the surface. Now, this protein, it has a receptor on the surface of enterocyte. You can see it is binding to this receptor. And once it binds to the receptor, it initiates a signal, a signal pathway within the cell that now instruct this particular cell to absorb calcium in the environment. So this cell now start absorbing as much calcium as possible. And then this is probably this is the same cell. This is just a demonstration. So it absorbs so much calcium that it then bursts and dies. So that is how this virus is able to cause the death of enterocytes. The function of enterocytes are to absorb food that has been digested. So when you eat food, the food mixes with saliva, it mixes with acid in the stomach and get partially digested. But for that food to get into your bloodstream, it must be absorbed by enterocytes. So if you had ingested rotavirus, it will actually just do this, get into one cell, produces new virions with a lot of NSP protein, which will now bind to all the cells in the surrounding, and they instruct the cells to absorb as much calcium as possible. And then these cells collapse and dies. And when the enterocytes collapse and dies, then the layer, the base of the stomach, the base of the small and the large intestine no longer have anything that can absorb digested food. And that is how then you end up with passing, loose stool, which we now call diarrhea. So I hope that is clearer to you how this virus, cause destruction of the enterocytes, leading to diarrhea. Now, this slide is more of a further explanation of what happens during the pathogenesis. So we are told that the virus first interacts with the villi. Villi are those projections on the enterocytes. You know, the enterocyte they have on the surface villi. So the virus normally interacts with the villi first, and then they get into the host cell, enterocytes rather, where they multiply, and then they damage the transport mechanism of the enterocytes. So these enterocytes no longer can perform the function of absorption of digested food. The one protein that is unique and is unique about viruses is the non-structural protein 4, which is an enterotoxin. An enterotoxin, we talk about toxins when we talk about the bacteria, but viruses is very rare to talk about toxins. And so NSP4 is one of the rare toxins produced by viruses. So please, you need to note that. So the viral, during this time that this is happening along the stomach, the small and the large intestine, you are also, you're passing loose stool, because now you don't have the ability to absorb, food. You are vomiting and diarrhea, but you are also shedding a lot of the virus, through stool to the environment. And this usually continues for 2 to 12 days in people who are otherwise healthy. People who are sick, it can continue up to 20 to 21 days or even beyond, depending on how immunosuppressed you are. And thereafter, you recover, because rotavirus is one of those viral diseases that have no treatment for rotavirus very well. So I want us to look at the symptoms due to rotavirus in infants in particular. The previous symptoms that we talk about are general symptoms for everyone. But remember, I mentioned that infants are the most at risk of dying due to rotavirus infection. And so as a doctor, it is very important for you to be able to identify an infant that is suffering from viral gastroenteritis caused by rotavirus. And there are symptoms that you can easily look at and be able to suspect, have high index of suspicion that this child is truly suffering from viral gastroenteritis due to rotavirus. Number one, fontanelle. Have you guys seen fontanelle? Children, fontanelle is here on the head. Children, infants, when they are born, I don't know whether you have witnessed this before. When they get dehydrated, on the head, you can see it's like breathing in and out. The fontanelle looks like it is breathing in and out. I don't know whether you guys have seen that. And so if a child is vomiting and diarrheaing and you see the fontanelle, sunken or moving up and down, that is one of the signs that this child could be suffering from gastroenteritis due to rotavirus. The other symptoms are the cheeks, the cheeks, the eyes are sunken, and the cheeks. The child is crying, but no tears, because they have lost a lot of water. There's no tears coming from the eyes. The mouth is also dry. There's no saliva coming from the child. And also the other symptom, which is also common, if you pull the skin of a child, usually infants have very tight skin. They're not as elastic as mine. The infant, you can actually pull the skin like the way you will pull for an old woman or an old man. This is not common with infants. It only happens when they are very dehydrated and suffering from probably infection due to a rotavirus. And then the abdomen is also sunken. You can look, you can see the abdomen here is sunken. So with these symptoms, if you see an infant kind of presenting with this, chances are that this child or this infant could be suffering from rotavirus gastroenteritis. But clinical symptoms alone is not enough to confirm that the child is suffering from rotavirus, gastroenteritis. You need to take the stool and do laboratory tests to confirm whether the child is truly suffering from rotavirus or not. Again, immunity to rotavirus infection. We are told that by the time you are 3 years of age, you have suffered a number of rotavirus infections, especially when you live in a developing country like ours, especially when you live in the village, not in town. Town, I think people live a clean life, which is not good for them. It's good because you feel good, but in terms of building immunity for future, it's not very good. So by the time you reach 3 years, a lot of children have developed serum antibodies to one or more types of rotavirus. This is purely because they have suffered, a few infections due to rotavirus and recovered. And when you suffer rotavirus infection disease and you recover, you build your immunity. Okay. Young children suffer up to 5, reinfections by second year. So this is one of those diseases where reinfection is very common. Now, in terms of the antibodies that provide protection, when you talk about protection, the protection is provided by 2 types of antibodies, IgA and also interferon. Interferon are not antibodies, though, but there are chemicals produced as a result of viral infection. They have been known to have a function of antagonizing viruses and making viruses not to replicate. So if you say someone is immune to a rotavirus disease, that person has got IgA-specific antibodies to rotavirus, but that person has also produced a reasonable amount of interferon in the body that when there is a new rotavirus coming on board, and either the IgA or interferon is able to fight the infection. Question. Why you guys know about 5 classes of antibodies? Is that correct? Which are the different classes of antibodies? IgM, correct? IgG, IgG, IgE, IgE, correct. So why does immunity to rotavirus is mainly IgA? Why is immunity to rotavirus mainly IgA and not IgM and IgG? John Kwani says it's a secretary. Anybody else? Why? Why is yes? The antibodies mainly produced is a mucosal antibody. Yes, correct. So I think you guys have had a good lecture on immunology. So antibodies are found in different parts of the body in different concentrations, and IgA are mainly found in secretory parts of the body. And a disease like rotavirus, which does not get into blood, the protection is mainly offered at the site of infection. So that's why IgA is the most suitable antibody for protection against this virus. So in terms of diagnosis, as I said previously, clinical diagnosis is not enough for confirming that one has an infection with rotavirus. You must take specimen, and the specimen of choice for rotavirus is usually the stool feces. And you can take it to the lab. They can do what is called ELISA. ELISA is an antibody-based test. They can also do a rapid test called latex agglutination assay, testing for rotavirus antigen. But the most common test currently used for the diagnosis of rotavirus is called PCR. PCR is now the most commonly used laboratory diagnosis for rotavirus. So in your practice as a doctor, do not attempt, well, because there is no treatment for rotavirus, do not attempt to use clinical diagnosis to make a final judgment that this infant is suffering from rotavirus. You may need to confirm by conducting laboratory diagnosis. Treatment for rotavirus, we don't have any licensed, antiviral agent that is used for treating gastroenteritis due to rotavirus. Usually, when a child is very sick, having diarrhea, vomited, the only mode of treating is to try to correct the loss of water and electrolyte in the body. So the sick person is given a lot of water and electrolytes to correct the loss of water, but that is what we call supportive care. It is not treatment per se, and so you should remember that. In terms of prevention is mainly targeting prevention of transmission. How do you prevent one from acquiring rotavirus? Knowing how rotavirus is transmitted through fecal oral, and as I said, you can acquire rotavirus by eating food which is contaminated with the virus, or by drinking water which is contaminated by the virus. Having known that, then the only way you can stop transmission is, number one, by providing safe water supply, especially those who live in towns, those who live in the villages. Also ensure that people have pit latrines or suitable toilets where feces doesn't end up in the river or in the ponds where people collect water. But the good news is that there's a vaccine for rotavirus. This vaccine has been there for a long time, and children are now being given this vaccine. As soon as after birth, the children are given vaccine. The only tragedy is that, despite the fact that the vaccine is still being offered, the rotavirus seems to be changing a little bit. So the vaccine can offer some protection, but quite a number of infants still are prone to getting rotavirus disease. So I want us to stop here. I want you to go and just the way I've taken you through the rotavirus, I want you to go and read about adenovirus 40 and 41. There's nothing much about these viruses because the most burden during to gastroenteritis, viral gastroenteritis, is due to rotavirus. Adenoviruses contribute, noroviruses contribute, but this is not as much as rotavirus. So in your own time, please read about this, these other viruses, just for you to understand how they contribute towards viral gastroenteritis. Good. So let me have a look at the chart. Bovine based, I don't know, I'm looking at your, I'm looking at the chart. So someone is asking, there is this notorious pediatric diarrhea that normally presents with sticky, green, loose stool in a company of smell, but painful swelling mostly in the calves. It is believed by the society around that every child must always be infected. Is it caused by viral gastroenteritis? No, that should be bacterial, my friend. That is a bacterial when it has a smell, and the mucus, sticky green mucus, that's a sign of dead bacteria. So that's gastroenteritis caused by bacteria. So you say that it is believed by the society around that every child must always be infected. Is it? So I want to say something about that. That those beliefs, they are good and bad. They are good in the sense that children who are exposed to many diseases when they are young, they build immunity which protect them when they are adults. There's something called hygiene hypothesis. Hygiene hypothesis talks around, why, you find asthma, for example. Asthma as a disease is very common to children who are born in town, but it's very rare in children who are born in the farms or in the villages. I want to give another example. COVID-19, when COVID-19 came, people in the whole world felt that Africa, we're all going to die like, rats. And many developed countries like China, started making body bags, to be sent to Africa, because people are going to die to the level that the mortuary would not be able to accommodate the number of dead bodies. But it turned out that there were very few people who died of COVID-19 in Africa, despite that we don't have very strong health systems. Further investigation then revealed that most Africans, they have been exposed to so many diseases, when they were young. And for this reason, that exposure seems to have helped in terms of providing them some immunity against COVID-19. Corona. How does coronavirus cause gastroenteritis? Did I say coronavirus causes gastroenteritis? No. Coronaviruses are respiratory, viruses. They mainly infect the upper and lower respiratory tract and the lungs. There was only a case during COVID-19 of some people who are found to be excreting the coronavirus in the stool, but that is because they were not actually, the virus was not causing the inflammation of the stomach and the small and large intestine. It's because when you cough and you swallow the mucus, it goes into the stomach and you release it through the stomach. So it will find itself now in the stool. It's not because the virus was able to infect the stomach, the small and the large intestine. Okay. So the other question here I'm seeing is from Lugman Aftin. What have you said about NSP4 as a viral enterotoxin? So what I said is that when rotavirus enter into enterocytes, they go through replication. Remember, the virus would start producing different parts of itself. Most of them are used to assemble to form new virion. But what is unique about rotavirus is that NSP4 non-structural protein 4, it's produced in very large quantities during the replication of rotavirus in the cytoplasm of the host cell. And this protein, it's not a virus itself, right? It is also released outside the virus when the new virions are leaving. And once that happens, then it has a receptor. The neighboring enterocytes have a receptor where the NSP4 protein can bind. And binding is like key and unlock kind of a thing. And that binding, the binding itself causes a signal within the cell, signals that now instruct the cell to start absorbing calcium from the surrounding, as much as possible. So it reminds me of a story of a long time ago when I was young in the village. We used to, target hyenas used to eat goats in our village a long time ago. And so one time a guy in my village became with a very innovative idea that because a hyena cannot differentiate between something normal and something abnormal as long as it has blood. So he collected, chips of stone and poured blood on them. And the hyena came and swallowed, these chips of stone because he thought it was eating some form of, dead goat or a sheep. And after eating quite a bit, it became so heavy it could not move. So it was people were easily able to kill the hyena. And so the NSP4 protein makes sure that these enterocytes that they have bound to absorb so much calcium that they burst. And when they burst, they die. And when they die, the enterocytes, when they die, then now you have left the surface of the stomach, the small and the large intestine with immature, eventually they will grow immature enterocytes which cannot absorb digested food. I don't know whether, Lukman, I've explained to you that very well. So Gabi is asking, what does bovine-based mean? I don't know where did that come from? Bovine? It destroys leading to malabsorption. Yeah, correct. So it also increases the secretion of oh, okay. So I can see, Gabi, you're talking about pentavalent human bovine rotavirus vaccine. So this is the vaccines are produced through many ways. Remember, I told you about some vaccines which are produced in eggs, right? Do you remember that? Yeah. So the rotavirus vaccine has been also been produced using bovine. Bovine is when a cow conceives, before it gives birth, you can actually remove the fetus. It's very rich in serum, and the rotavirus grows very well in serum from bovine. So you use that serum to produce rotavirus. So that is what is called the role of bovine in this. It is just based on the fact that rotavirus replicates very well in serum from unborn calf. 1 second. No. Bwana Zongok, today you are speaking like a scientist. You're asking a very interesting question. The question is, does yes, COVID can cause diarrhea by disturbing the microbiota? Who knows what microbiota is in this class? Can I see from the charts? What is microbiota? You know, sometimes when you read big books, you get jargon words. So you can, as a teacher or to your colleagues, what is microbiota? Anyone who knows what microbiota is? Normal flora, normal flora, normal flora. Okay. So, so you guys are reading a lot. I'm very impressed. So the microbiota is a terminology that describes normal flora. And normal flora are found in different parts of the body. You can find normal flora in the mouth. You can find normal flora in the stomach. Normal flora in the vagina, right? Normal flora in the eyes, right? So all those are microbiota, right? So what I wanted to let you know is that coronaviruses can be found in stool. As I told you, I can even share with you a publication where someone had reported that during COVID-19, they were able to recover COVID-19 from stool samples. But the mechanism on how those viruses ended up in the stool was because, the virus would cause sore throat. They'll be coughing. When you cough and you swallow the mucus, it goes into your stomach, and in the stomach, the virus will be released in the stool. It doesn't mean that that virus was actually replicating in the stomach. So we are talking about viruses which can infect and replicate and cause inflammation in the stomach, the small and the large intestine. That is what we are talking about as viruses that cause gastroenteritis. Good. Any other question? So I think we are done with this topic. I'm not sure whether I'll be able to do the 11 to 1 class because of my voice. I'll keep on drinking lemon. If I feel good, we shall have the lecture. If not, I'll have to request that we have a lecture, make-up lecture to cover that. I've really struggled to deliver this lecture because of oh dear, someone is asking me about, what about microbiome? Okay, you guys are reading internet. Microbiome refers to a group of bacteria. Microbiome refers to a group of bacteria that lives within a locality in your body. So we have the gut microbiome, we have this the mouth microbiome, right? These are mainly referring to bacteria, not other infectious agents. And these bacteria, they produce probiotics, which as I can see, Roy Oluga is showing us here. They produce probiotics and prebiotics and probiotics. And these are, things that also fight other infection, dangerous. In your body, you have the normal flora, which protects you, but you also have other bacteria which are pathogenic. But remember, we are not talking about bacteria in this class. We're talking about viruses. So let us stay within our lane. Let us not divulge too much out of virology. So, so I want to thank you very much. I think it's almost 9 o'clock. I'm sure you are going for another class in the next few minutes, I believe. But Chelsea, if my voice doesn't improve, I would request that we look for another time to deliver the lecture that I'm supposed to deliver from 11. And then we shall continue from there. Asanteni sana, and have a great day. Bye-bye.
Thank you.
I can see people are already prescribing for me drugs. This is great. Thank you very much. Good day.